So up to this point, what we've done is two equations with two unknowns. So now we want to expand that a little bit to systems of equations where we have three equations with three unknowns. Okay, so the graph of a linear equation with three variables is a plane in space, in three space. I say three space because we have 4 space, 5 space, 6 space. It just tells you how many variables you have, actually. Okay, but anyway, there are 8 possible types of configuration of 3 planes in 3 space. Now, you don't have to memorize this. I just want to show you what's going on physically. So you can have 3 planes that are all parallel. Okay. You can have 2 planes that are the same and a third one that's parallel but not the same. Or you could have 2 that are parallel and 1 plane that intersects both of them. And so it's going to intersect one in a line and another one in another line, and those 2 lines of intersection are going to be parallel. So you'll get no solution for that, right? Or you could have something like this, where they intersect in pairs, the planes intersect in pairs, and wherever the lines of intersection, the 3 lines of intersection, are parallel to each other. That's what this is supposed to be. So this line, and this line are parallel. So there's no point that lies on all 3 planes, so there's no solution. All of these have no solution because the solution has to be where all 3 planes intersect. There's points that are common to all 3 planes, and there aren't any that are common to all 3 planes for any of these 4. Okay. Now this one, you have 3 planes that are all the same. This one here, 3 planes are all the same, so you have infinitely many solutions. It's all the points in the plane, right? So that one's consistent, but the equations are dependent. This one, we have 2 planes that are the same, and then one that's not the same and not parallel. And so your solutions are going to be all the points on this line. So that's dependent and consistent, has solutions. Then you could have 3, what we call like coaxial planes. 3 planes that all go through the same common line, but no 2 are parallel. Not like this one. And so again, you get a line of solutions. So it's dependent and consistent. And then you could get this kind of thing, and this is where the 3 planes intersect in a single point. And that's when you get one solution. That's the one that we actually like the most usually, is this last one where you get one solution. So those are supposed to represent 3 planes that intersect at this point here. Okay, there's this plane on this side, this plane on this side, and then the plane in the back side. Okay, so that's consistent and independent. That's the solution. So I'm coloring in the solutions for each one. The bottom 3 have solutions. Bottom 4 have solutions. The top 4 don't have solutions. So the top 4 are inconsistent. The bottom 4 have solutions. They can be a full plane, a single line, which is either one of these types, or a single point. Those are the possibilities. So I just wrote over here on the left, inconsistent, no solution for the top 4. Consistent, which means it has solution or solutions, 1 or more. The solutions here are labeled underneath: a plane, a line, and a point. Unique solution. And the one with the point is the one where they're independent. The 3 equations would be independent. So these are what can happen, the different things that can happen. You don't have to identify which one's happening in each case. But if you get a single point for your answer, it's definitely this one. But just so you realize, you could get a line, or you could get a whole plane of solutions, or you could get no solution at all.